Thank you, ma'am, for the warm welcome and for the invite and giving on the talk of deep learning with Python. All right, and this is the final session, I suppose. Should we need to wait? Are the participants joining, or we could start with the session, ma'am? Will be joining. Okay, okay. So how was these all sessions for you? Hope you all should have enjoyed the different sessions that you have been doing it for the last 5 days, and this is a final day, and this is the final session, right? So always it's an exit of this session, and then we are going to see about deep learning using Python. How many of you are good today? How are you today? Can I have your answers on chat, please? How are you today? Those are connected, you can give your answers on chat. Yes, Akila ma'am says she's great. Others, Nisha ma'am says that she's good. We've got a list of faculties who are joining now, like Parameshwari ma'am. Okay, each of you are saying that you're good, you're great, and that is really a good sense when we want to hear during this pandemic. You know, Omicron, they keep saying it, but today we have all gathered together to learn something more, to learn or to unlearn. All right, and I hope my audio is, you're able to hear my audio and my screen is getting loaded. Once the screen is loaded, one of you can unmute and say whether you're able to see in my screen. Thank you, Suja ma'am, for your response that you are good. Are you able to see my screen?
Yes, ma'am.
Okay, thank you. So today, how some of you would have been working on machine learning, some of you would have been working on deep learning, on AI or reinforcement learning. Different learnings are there. All right. Learning. What is the difference between learning and studying? Anybody, can you say difference between learning and studying? How many of you know to drive cycle? Type yes on the chat or you can unmute and say. எத்தனை பேருக்கு சைக்கிள் ஓட்ட தெரியும்? Nobody knows? Yes, Kalai. At what age you learn to drive cycle? At what age you learn to drive cycle? 10 years, 13 years, okay. If I give you a cycle even today, will you be able to drive? Yes or no? If I give you a cycle today, I am not going to ask what is your age. Yes, you will be able to. Kalaiselvi ma'am says, Kakila ma'am says, yes. We have learned before 40 years or 30 years or 20 years, but still if I give you a cycle, you'll be able to drive cycle. I know most of you have got very good marks in 10th and 12th. If I give you the same 10th standard question paper, what you have learned in the 10th standard, will you be able to score the same marks of what you've scored in 10th standard? No? Yes or no? No, Akila ma'am says no. Yes, we will not be able to score because that is where the pattern of studying, driving cycle is a pattern of learning. Can you find the difference between two words, studying and learning? Studying, it stays for some time and then you may forget. But learning, whenever, see, you, Kalaiselvi ma'am learned to drive cycle when she was 10 years old. I'm not going to ask what's her age now, but still even today she can drive a cycle. See, that find the difference between the word studying and learning. Yes, study means to read, memorize, learn means to gain knowledge or experiencing something using a hands-on session. You drive learning things, okay, where in which you will be able to work on with that, where you'll be able to work on with that. Now moving on to a session. All right, so today for the next 1.5 hours we are going to see about deep learning using Python. So Kalaiselvi ma'am has given the introduction. So to start with deep learning using Python, we have to work with data sciences. Okay. So what is a data science? Science, always you think what the different sciences that you should have learned, physics, chemistry, botany, zoology, it's all learning about life sciences. So here when you come into data science, it is an interdisciplinary field, all right, where you use scientific methods to process algorithms and the system will be used to extract knowledge either from structured data or unstructured data. Say, for example, if you are going to work with Microsoft Access or an Oracle database, all right, those things are structured data. Those are structured data. If you want to do an analysis of, say, for example, if you want to do an analysis of your Twitter sentimental analysis, which is consisting of only text, okay, those text of data, all right, it is of unstructured data. It's of if you want to do an analysis of your Facebook post, all right, which is an unstructured data, all right, and some data types are semi-structured data. So listen to the talk very, very carefully. At the end of it, we are going to play a live quiz. We are going to see who's going to be the winner of today. Some of you are joining now. All right, we have just started with the introduction of learning and studying, and then we have jumped into data science. All right, so here, not only you're going to get instructed, you're going to apply knowledge onto it. You're going to apply knowledge onto it. Actionable sites from data across broad range of application domains, from broad range of application. You're applying the knowledge, whatever we have learned. All right. So when you have a data, it is a scientific method. You've got huge, say for example, it is Vistas. Vistas, how many years it is old? How many years old is Vistas? One or whichever college that you're working, all right, can you give me a response? How many year old is your college? Answers on chat or you can unmute. Let's be a little more quicker. How many years old? If you ask what's your age old, you can say. I'm asking the question, how much year old is the institution that you work on? Oh my God, no answers? Yes, no. At least give me some approximate answers. 50 years old, 20 years old, 10 years old, 5 years old. You're able to hear me? Is my audio clear? Hello?
Yes, ma'am.
Yes, ma'am.
Okay. Sometimes I get doubtful whether my audio is not clear. Yes? Okay, if you say for 15 years old or 20 years old, imagine how much huge volume of data your college will have. How many students were studied, how many students passed, what is their current position, how many faculties were there, the teaching staff, non-teaching staff, those who are meant to on roll, those who have left. So if you have a visualization of it, okay, that could be done using data science understanding. So these many students are joining, say for example 1,000 students are joining, and if the third year or fourth year 800 students are passing, 200 students are failing, the next year the 800 should become 850 pass, and this should come low. Okay, to make an actionable sites, to take the action work, the action goals, all right, data science plays a vital role. You can apply whatever application that you do on. The three most important Python library files that you need to know for data science is called NumPy, which stands for numerical Python, where you can work with numerical process like a Laplace series, all right, Fourier series, Fourier transform, and Pandas is used for data analysis for different kinds of visualization, extracting data from a normal CSV file, or it could be an Excel file, or it could be in Hadoop. If some of you are working with big data analytics, all right, if it is you're working with Hadoop, if you're going to get an Hadoop distributed file system, if your file type is of HDF, also you can work with Pandas. SAS. All right, whatever is the type of data you'll be taking. Today's session I'll be showing how are we going to take a CSV file, how are we going to use it, develop a modeling using deep learning model. All right, and then Matplotlib is used for plotting it, for visualization. If I'm going to give you 2 lakhs of data, remember, if I'm going to give you 2 lakhs of data, you will not be able to go through all the pages. But see, if you're going to have visualization, within a fraction of a second, you will be able to infer informations from the visualization of chart. Always remember, when you are a data scientist or a data analysis, or you're working with machine learning or deep learning algorithms, the first step is called as exploratory data analysis, where you visualize the data center. Remember very carefully, you need to write inferences for it. You need to write it. What do you infer from the data set? What do you infer from the data set? And the next level of visualization is called seaborne. SEABON. This is a higher level user interface in comparison with Matplotlib. Today's session, I will be showing you of both. Okay, how it is used in Matplotlib, how Seaborn is used, you will experience the difference. Right? Is there anyone who has been working on Python libraries, whatever I've shared, NumPy, SciPy, Matplotlib, Seaborn? Yes, no? Yes or no? Have you ever, those who are working listening to this talk, have you worked on? No, Kalaivan sir, no. Others? There's so many people, you can give your responses. See, the only way that we could know that people are really connected is only through the response that you give to us. All right. No. Okay, some of you say no, some of you say yes. I'll be showing you a demo session. We're not going to have an hands-on session. See, and slowly from webinars, we are going into live workshops because yesterday I had sessions, last week fully I had sessions. Tomorrow I'm having a live session in a college, like 2 hours, 1.5 hours of theory and 1.5 hours of lab in live at their own institution. Right? Slowly we are moving into it. Okay. So today we are having this webinar. So I'll be showing it to you how it works. Okay. So when you're going to speak about deep learning, definitely we need to speak about machine learning. Okay. What both machine learning and deep learning, they try to discover patterns in data. See, when how many of you know very well about your friend? How many of you have got a friendship that has lasted more than 5 years, 7 years? Have you got your friend? Have you got anybody has got friends more than 5 years, 10 years, 15 years, 20 years? Yes, no? Yes, me and actually ma'am says yes. How many? Which friend you have the longest year? Longest year of friendship? Can you type in the year? Or you can
Ma'am,
unmute it.
ma'am, school friends, ma'am. Still, I'm in touch with my school
How
friends.
many?
Last
Ask question.
25 years. Yeah, 25 years, ma'am.
25 years, okay. So it's nice. Sir says 25 years friendship. See, when you see your friend for the first time, you would have not known more about him. But now, see, it's 25 years. Like Kalavan and Sir is here, his school friends will be distributed in different places around the world. But still, he'll be able to understand about his friend. He knows this friend, he likes this food. This friend likes this kind of character. This friend. So this is how we try to learn patterns. The more time we spend, you imagine your mother when you go to your parents, no, they know what food you like. If you're going after so many years, my son, my daughter will like this food, shall I prepare it for them? Though they are able to do it or not able to do it, they definitely prepare it. For your children, this food my son likes, this food my daughter likes. See, you're trying to discover. If you've got 2 children at home or 3 children at home, all the 3 are unique and 3 have got their own interest factors. All of them are not the same. The same way here, when you take machine learning and deep learning, both learning, they involve to discover patterns. Say, for example, so many students have studied in your college, so many students have passed on. How many after 10 years, how many of them highly placed? Are they getting job? Or they're not getting job? For all, you're trying to discover patterns from this data. So many faculties, they have been into teaching field for so many years. What is the result they produce? All right, so that you'd be able to find it out. All right, both machine learning and deep learning, they are involved to discover patterns from data, but they involve in a different method. When you take, so both machine learning, deep learning, but both they'll discover patterns of data. So machine learning and deep learning are both forms of artificial intelligence. In 17th session, I was speaking about artificial intelligence in CPS. Hope some of you would have remembered what we have seen. Okay, machine learning and deep learning are both, they are forms of artificial intelligence, right? Deep learning is a special kind of machine learning. Okay, in both, listen carefully, listen very carefully. Both machine learning and deep learning, they are working with training data and testing data. And then they go to a model. Then we develop a model, and it goes to an optimization process to find the weights that makes the model best fit the data. So always, since you are all into the teaching sector, you're all into the teaching sector. Even I was in teaching for more than a decade in different in engineering colleges and for different designations already. So during the course of the semester, we may give students to take the model exams, the what do you call that, internal exams, CAT exams, so many exams. This is the training phase. When it comes to the end exam, so this so these students have learned on the first CAT 1, CAT 2, CAT 3, or internals 1, internals 2, internals 3, and they have taken a model exam. Then they know this child will definitely pass. If the child doesn't pass, then you give some special class or give them more insights to it. All right, so that is the training data. After the training data, the student passes or fail. The testing data is the students who are there taking the university exam. Okay, the students are taking the university exam. So even before the university results comes, you will know you would predict these students will definitely pass, these will not pass, these are some doubtful, right? So that is one part of learning, because you're spending time with the students for a semester. Right? The training data, you can compare it with the internal exams that you take, and testing data, you can compare it with the final exams the students take, and the label data, whether the student is going to pass or not. All right, so a model is going through a process of optimization, and you find if the students during the exams, if the students are not doing well, you keep some kind of special classes, all right, and then you try to mold the students, train them up to the mark, give them some questions out of 5 units, try to learn 3 units, this and that, or permutation and combination, you do it. So same way here in both machine learning and deep learning, you are going to have both training data and testing data. Training data and testing data. So training data, what is a target. Testing data, it's a totally unlabeled data. Say, for example, if the person's diabetes of this level of sugar before fasting, before food, after food, and different parameters, if you take the glucose tolerance level, whatever the parameters you take, then you have a target, which means this person is diabetic or not diabetic. All right. So when you have a target, you call it as a labeled data. If you don't have a target, you call it as an unlabeled data. During the training phase, you'd have both the content, the features of it, and the target. During the testing phase, you have only the features, the model that you're going to develop. All right. It is going to give you, all right, the model what you've developed, it is going to give you the predicted results, and there you're going to compare with your original results. All right. So artificial intelligence, again, already we have seen, it is a machine capable of doing it on its own. Okay, the subset of artificial intelligence is machine learning. Okay, here also it discovers patterns. Here it acts as machine is trying to do things on their own and try to explore, and they try to explore things on its own. Extract patterns, both machine learning and deep learning, they extract patterns on their own. All right, a subset of machine learning is deep learning. Okay, subset of machine learning is deep learning, but here in deep learning you use deep neural networks. You know how the brains are connected with neurons. It is trying deep learning, listen carefully, professors. Here, deep learning is trying to develop a model that is mimicking the brain, but definitely it cannot mimic the human brain. So here, when you compare with machine learning with deep learning, okay, deep learning provides better accuracy, or you can say a higher level of accuracy in comparison with machine learning. All right, because deep learning uses deep neural networks. Deep learning uses deep neural networks. All right, so far you're able to understand? Yes, no? The whole section is artificial intelligence, the subset is machine learning, and the subset is deep learning. All right, you're able to understand till now? Yes, no? If it is yes, type Y on the chat. If it is not, type N on the chat. Thank you, Suja ma'am. Thank you, Akila ma'am. What about others? There's so many people here. If you find typing yes, ma'am, just type Y, N, just type N for no. Yes, thank you, Meenakshi ma'am. What about others? This webinars always, I think, when we have an interaction only, we know really people are listening, or they just switch off, they get connected to the Google Meet or Zoom and then they leave off. Okay, no problem. Okay, so listen to the talk very carefully. Okay, so when you take machine learning and deep learning, both can handle numeric problems. That is the regression, say for example, stock price prediction, which is a continuous valued variable, where you work with numerics. Non-numerics, it's classification problem. Okay, here you're whether this person is going to have a disease or not, all right, whether this product is going to sell or not, whether this student is going to win or not, all right, sorry, this student is going to pass or fail, all right. So many, both can handle, both machine learning and deep learning can handle numeric data and non-numeric data. Okay, and then applications such as object recognition, language translation. Is any of your researchers here who works with NLP? It stands for natural language processing. Yes, no? Anybody of you here, you work with natural language processing? Yes, no? Okay. No means type N, yes means type yes. Why? All right. All right. So when you take deep learning model, it provides better fitting than machine learning model. Especially, thank you, Kalaivanan sir. Okay. There are a lot of research areas available and we need to explore things and how it could be working. All right. And then when you take applications such as object recognition, you show an image and the image will be recognized. Okay. When how many of you are using Google Lenses? Maybe in the last session, I should have told you about Google Lenses. It uses artificial deep neural networks. Okay, so deep neural networks, it produces better fit in comparison with machine learning. It provides better fit comparison with machine learning. Okay, so deep learning is considered to be an evolution of machine learning, because here, listen carefully, it uses programmable neural networks. Okay, that make accurate decision without help of humans. We saw about Sophia the robot. You remember? It is a strong AI. You remember we saw in the last session, right? It is a strong AI where it was able to make decisions on the own. Whereas you take Google Assistant, Siri, Alexa, it was weak, which needed some help. Okay. But when you take deep neural networks, they'll be able to take decisions on their own without the help of human. Deep learning is machine learning. So algorithm that passes the data, learns from the data, applies what they have learned to make informed decisions. Say, for example, if a student is going to take 5 subjects, so I'm going to develop a machine learning model with all the 5 subjects for CAT, internal 1, internal 2, internal 3, whatever marks he has got, and also along with the result. Okay, is going to pass or fail. And out of which, if I'm going to test it, I'm going to give for the testing model only the marks of the students, not the result. But my model will predict and say whether this student is a passing student or is a failing student. And then you get this predicted result, you have your actual result, you compare your actual result with the predicted result, wherein you get your accuracy. Okay, wherein you get your accuracy. Very rarely you'll be able to get 100% accuracy, but basically if you get more than 80-85% accuracy, it is really a sounding algorithm. It's really a sounding algorithm. So whenever you give in your, from whatever it has learned from the data, on the training data, say for example, if it is less than 40, the student will fail. If the student has got on the internal 140, on the internal 250, on the internal 260, which means the student on to the final exam, he'll be able to get between 55, 60, right? Or it could be even 60 plus. So those kinds of, once it learns the information from the data very carefully using the machine learning algorithm models, and it applies to the testing phase from the patterns it has learned, from the data it has learned. Okay. So moving on to example of machine learning is recommender system. How many of you watch your YouTube videos? YouTube. Yes, type yes on the chat. No, I don't see YouTube. You type no on the chat. Let's be quick. How many of you see YouTube? Hello? Whether you watch YouTube or not. I hope you're able to hear my audio. Okay, you can give your answers on chat. No, you don't see YouTube at all. Yes, but with the limit. Okay, everybody, even I watch a lot of YouTubes, right? We watch a lot of YouTube, and then what happens is that you use YouTube. Can you see whatever video you see? You can see a relevant video onto the next popping up. Have you experienced it? Say, for example, if you're going to watch a cricket, you can see the following cricket onto the next video. If you're going to watch some songs, a devotional songs or whatever it is, the next song will be a devotional song. Yes, this is an example of recommend. It learns the patterns. And also when you open YouTube, you'll be able to find what you are searching, the same kind of content comes onto the YouTube. All right. Here, this is an example. It learns from the pattern of your searching. What kind of songs you like to have, a fast number or a slow number or a soothing number, or it's devotional or it is news. Okay. It accordingly you can see when you open, accordingly it learns the patterns, and according to that it is providing you the services. This is an example of recommended system. And then how many of you are using Amazon, Flipkart? Yes. Have you seen people who have viewed this product have also viewed this product? Say, for example, what is the latest product that you bought from Flipkart or Amazon? How many of you are buying things in Flipkart or Amazon? Groceries. Can you see the people who bought this also bought that? And also, can you see some offers related to it? A deal of the day? Yes, those are examples of recommendation system. It learns from the pattern of your search and it is trying to recommend it. All right. So these kinds are examples of machine learning algorithm. When you come into deep learning algorithm, machine learning models do progressively better, and each time they need some guidance. If an AI algorithm returns an inaccurate, then the engineer tries to step in. If the accuracy is not go, we go in for hyperparameter optimization. All right. Whereas with deep learning and algorithm, it can determine on its own without help and makes an accurate prediction. And it makes an accurate prediction through its own neural networks. Okay. Say, for example, if you have developed a program in your room, okay, when you come inside the room and if you say it is dark, the light switches on. So machine learning algorithm can work only if you say the word dark. You come to the room and you say dark, the voice recognition captures it, converts your speech into text, and it switches on light. But whereas in deep learning algorithm, if you have developed using deep learning algorithm, it is not only you need to use the word dark. Why can't I see? Is the light not switched off? If I use even these phrases, also it will be able to extract the information, able to make it sense, and then try to switch on the light. Can you find the difference? In machine learning, always you need to use the word dark to switch on the light. In deep learning, because it learns from its own, from the past experience and the current experience, trying to assimilate the data and extract meaningful information from it, and it acts accordingly without much intervention of human or no intervention of human. But in machine learning, there is a need of interventions of human being involved into it. And the accuracy of deep learning is more in comparison with machine learning algorithms. Able to understand? So when you take machine learning, you can directly, you have to say only the word dark. But whereas in deep learning, you can say the light is not switched on. I think I cannot see here. Some of the words, if you could use also, deep learning algorithm will be able to find it out. Able to find the difference between deep learning and machine learning algorithm? Those are listening to this talk? Yes, no? Okay, let me get your answers on chat. Okay, more than 30 people are here. Let me get your answers on chat. Hopefully, I'll get answers on the chat session. All right. So now when you take deep learning applications, they use layered structure of algorithm called artificial neural networks. Okay. Here I said you are mimicking the human brain. Okay. It's a biological neural network of human brain. It is inspired by the biological network of human brain, leading to the process that is more capable of than the machine learning. It's more capable than the machine learning algorithms. Right. So whether you're able to find the difference between machine learning and deep learning, yes or no? Answers on chat. Yes? Able to understand the difference between machine learning, deep learning? Am I audible? Some of you, can you unmute and speak? Hello? Okay. Sometimes I think if there is no response, I'm missing some audio problem. So one example of deep learning, I don't know how many of you know about this program, this game called Go. It is kind of a chess game. Okay. So Google created a computer application. This is an example, a live example of a Google product that completely works on deep learning algorithm, right? So Google created computer program with its own neural networks. Okay, they learn to play on an abstract board game called Go game. Okay, which requires sharp intellect and intuitions, right? So the AlphaGo is a deep learning model developed by Google. Okay, so it is like playing a human playing with a computer. So they have made a called AlphaGo, all right, and from which they have called one of the greatest players of the world to compete. This is the website of it. This is the AlphaGo's website. Okay, so this entire thing, AlphaGo is a computer game. Okay, it's the most challenging game, and it is developed using deep learning. Say AlphaGo is the first computer game. Okay, defeats professional human Go players. The world's champion. Okay, who said on the earth he is the best player. He was playing with AlphaGo. Go is a game of this. Can you see on the screen? This is the Go game. Okay, it's originated in China 3,000 years ago. Okay, which requires multiple layer of strategic thinking. All right. So even this, then when Google created this AlphaGo, a computer game, all right, they were able to combine it. Okay, they were able to combine it, and then this AlphaGo defeated the world's best, the world's the world's best Go player, so strong is the deep learning models that has been developed. So strong is the deep learning model that is. So when you compare with machine learning and deep learning algorithm, the machine learning algorithm is less, comparatively gives a less performance in comparison with deep learning. It is almost the same when the data are of small size. When you work with big data, deep learning provides you a better results. Deep learning provides you a better results. All right. So, both deep learning and machine learning, they use algorithm to parse data, learn from the data, and make decisions from what it has learned. Okay, but what deep learning structures they do? They create an artificial neural network. Okay, that can learn and make intelligent decisions on its own. They are creating a artificial neural networks. Okay, they're creating a artificial neural networks. I told you it is a structure of the biological structure of human brain. So when you take deep learning, it is a subset of machine learning, where both falls into the category, but deep learning is more powerful. It is like human-like intelligence. It's kind of human-like intelligence. Okay, so these are something that you need to strongly know about machine learning and deep learning. So now moving on to the different types of learning. Okay, and supervised learning and unsupervised learning. So for best example, when you go to a college, a regular college, and you learn, you have a teacher who teaches, you go to college, spend time with them, and you take up the internals, and then you take. Some of you, have you learned anybody of you have learned through anything through distance course? Or what do you say, correspondence course? Yes or no? So where you don't go to college, you get the resource materials, you learn on your own, and you take up your exam. So that is an example of unsupervised learning. This is example of supervised learning. I hope that you are able to understand. So when you have a supervised learning, you have a target variable. You have a target variable. The supervisor will know whether the student is going to pass or not. But in distant education, they will not know whether the student is going to pass or not, because they don't have any of your data as much. Okay, so you have a training data, and what is your output, and you develop an algorithm, and it goes to the processing phase. And see, I'm giving you the training of a apple structure. It takes the structure of an apple, the color of the apple, but during the testing phase, instead of a red apple, I'm going to give a green apple, but still my machine learning model will be able to find it out. It is an apple. Okay, so if you're going to give a banana as an input, no, it says no, it's not an apple. All right, it cannot say it's a banana, it can say no, it is not an apple. So this is how is an example of supervised learning always contains a label data. When you take unsupervised learning, okay, you don't have a target. This algorithm will try to go and find the features. See, there is the unknown output. But when you see the previous one, here you have a known output. Yeah, but can you see here? I'm not sure whether you're able to see. It's a desired output. You know what is your output. Whether these parameter, the student will pass or fail. This parameter, this person is going to have a disease or not. This parameter, you are going to buy the land or not. This parameter, whether you are going to this sale is going to win or not. Okay, you are going to attend or not. You have a desired output. Where it comes into supervised learning, where you don't have an output at all, but you give the data it from unknown outputs, no training data. It finds the features of it and then develops an algorithm, so and it processes it and gives an output. There are 3 clusters. So can you see, apple is one cluster, banana is one cluster, mango. Classification algorithm comes under supervised learning, clustering algorithm comes under unsupervised learning. Is it clear? Classification comes under supervised learning, and the clustering algorithm comes under unsupervised learning. Okay, post-lunch session is always challenging. That's what I keep asking questions. So I hope you're into the talk and you're listening to it. At the end of this, when we play the game, we'll know how many of you are really listening to this talk. All right. And here, if you see the difference, the next difference between machine learning and deep learning. In machine learning, first you extract your feature and then go in for the classification. Okay, the classification is followed by feature extraction. Once the feature extraction is done, then classification comes into play in machine learning. But here, when you take deep learning, the classification and the feature extraction goes hand on hand. It is not see, first it runs to, can you see, you have an input layer, you have an output layer, you have several middle layers into it. So it moves from the front to the last, it gets an output, it goes again from the first, learns a new pattern, it goes to different iterations, or you call as epochs. So it goes front to back and back to front, and that is what the accuracy of deep learning algorithm is more better in comparison with machine learning algorithm. Okay, you give your input, different extraction, and you get your output. Okay, so feature extraction is one phase, and then classification is another phase in machine learning. But when you come into deep learning, feature extraction and the classification algorithm goes hand on hand. It goes hand on hand. All right, and see, when you take, it's unsupervised, you don't have a target. All right, you have a new data. Okay, you give both into it. See, here feature extraction and grouping of objects have been done, and then you go into a deep learning algorithm, and this again goes hand on hand, the feature extraction and the layer, and then you go in for your results. Okay, it's not a separate thing, it goes hand on hand. So what are the different deep learning applications that you can work on with? Okay, the different deep learning applications are instant visual translation, Google Lenses, predicting the future. We don't know what is going. We are almost at the end of 2021. We are going into 2022. The chatbot, right? How many of you have experienced chatbot in different web application? Yes, type Y on the chat. Whenever you open some web application, the chatbot automatically pops in. How many of you have experienced it? Yes or no? Hello? Yes, Akila ma'am answers. What about others? There are many people. I don't know, you're really into the talk. Thank you, Lakshmi ma'am. Thank you, Chandran sir. Okay. If you're not speaking, you can put your mic on mute. Okay. Thank you, Danya ma'am. Okay. So those are, thank you, Bharanidharan sir. Okay. Those are examples of, those are examples of deep learning model. It automatically asks what is the service that you need from us. Okay. And even you use GoDaddy, and then after something, then it goes and connects to the real person. Medical care, a lot of application in healthcare, you uses deep learning models in images. Okay, self-driving cars, Tesla cars, right? Galileo's cars. So those things, they work with deep learning models, colorizing the images. Okay, in image processing, reading the lip movements, now yesterday, I don't know, sometime day before yesterday, I got a message on my WhatsApp giving like one person in Kerala has worked with image processing and giving like to Bhagat Singh. From the Bhagat Singh picture, he's trying to move his lips and the eyes from the photos. Right, there is a real example of deep learning algorithms. Okay, from Kerala, one person has worked on, a researcher has worked on photo descriptions, deep dreaming, and advertising. Have you seen the Google AdWords? Have you seen when you search for something with your login, when you open Gmail, you will see the same advertisements coming. So those things, they are working with deep learning algorithms. Okay, deep learning algorithms. So what are the steps? What are the steps involved in developing a deep learning model in Keras? First step, you need to load the data. Second step, you need to pre-process the data. Pre-process the data means machine learning algorithm and deep learning algorithm cannot work with categorical values. Listen carefully. Categorical values with strings. It can work only with numerical values. Say, for example, if your data set is going to contain a traffic in one column. Okay, what are the colors in traffic? Traffic signal, what are the colors? Everybody should have crossed some traffic or the other. What are the colors onto the traffic? Oh my God. No answers. What are the three colors in a traffic signal? Red, green, and yellow. Thank you. So red means you stop, yellow means you be ready, green means you go. All right. So if your data set has got one column, say for example, you've got 10,000 datas, 10,000 rows, and one column has got different values: red, green, blue, red, yellow, green, red, yellow, green. Your machine learning algorithm or deep learning algorithm will not be able to understand from it. So you need to convert these categorical values into numerical values using label encoder. Maybe 0, 1, 2. There are different, if you have got so many values, SkyKit is the module that they work with, where it pre-processes the data. SkyKit, okay? SCIKIT. If you're making a note of it, you can make a note of it. SCIKIT. All right, so through which it will be able to process it. Then you pre-process, you have to define what model you're going to use and how are you going to compile, how are you going to fit, how are you going to evaluate, what is the required predictions, and saving the model. These are the basic 8 steps to develop your machine learning algorithm. Okay, machine learning algorithm. The first, you need to load what is the data set that you're working with. It could be a heart disease or kidney disease or any kind of, or it could be some cyber securities, or it could be some sales that is going to win or lose, or it could be an academics, or it could be something, whatever is the data. You need to be very, very careful in defining what is the data set that you're going to work. So if there are some researchers here, I advise you all to use UCI machine learning repository to develop algorithms. because those data sets are benchmarked data sets. Those data sets are benchmarked data sets, right? Where you can directly take those data and first you need to load the data, then pre-process the data. See if you are going to have some missing values, you need to remove the missing values. You need to work with imputation functions. All right, if you're going to have a categorical, convert the categorical value to numerical value, and supposingly if you want to do a normalization or scaling of values, those all these things comes under pre-processing the loaded data. And then you have to define what Keras model that you're going to use. Okay, and then you need to compile the data. Okay, during compilation you need to define what is the loss function, what is an optimizer, what is a metric. Three things comes in compilation. Those are making a note of it, you can make a note of it. During the compilation in deep learning model, you've got three things. One is the loss, second is an optimizer, and the third is what metrics you have used. See, inside loss, there are different kinds of loss in Keras model. Okay, when you take optimizer, there are different optimizers. We are going to see in today's session, all right, one such optimizer problem and how the data set is going to work on with. All right, and then what kind of metrics? Is it accuracy or so many metrics are there? Once it is done, then you need to fit the model. After you compile, first you load the data, you pre-process the data. Second step, third step, you define what model, that different model, sequential model, or some, if you're well expert, you can start driving your model right from scratch. Okay, fourth is compilation. Compilation, I told you three steps. What is, you need to give your loss function, you need to define your metrics, and also an optimizer. So after these four steps are over, the fifth step is to, you need to fit the model onto it. After you define all the parameters, you're fitting into it. Once you fit the specified model, then you evaluate it. Okay, so you get your prediction, you evaluate it, whether the accuracy is how, and what are the required predictions that it has done. And at last, the eighth step, you save the model, and the same model you can feed in for the future purposes. The same model we can use it for the future purposes. Able to understand this eighth step? You're going to go step by step. Are you able to understand till now whatever we have seen? Yes, no? Yes, thank you, Suja ma'am. What about others? Okay. So Keras is the Python library that provides a large and wide range of deep learning algorithms. The backend, there are other libraries, TensorFlow, Theano. For today's session, we are going to use TensorFlow for backend. For the Python libraries, where it contains a huge volume of deep learning models, it is Keras. Okay, so Keras is the model, the input and output, the backend libraries that you're going to use. You can use TensorFlow or Theano. For today's session, I'm going to show a demo using TensorFlow. So what it enables faster experimentation through higher level user-friendly modular and extensible API, application program interface. All right, application program. So when you take Keras, it has got thousands and thousands and thousands of deep learning models. According to your application, we need to try which model suits the best. Okay, which model suits the best, for what layers you need to work, how many approaches you need to work. Is there any kind of optimization technique that you really need to do it? So Keras can work on both CPU and GPUs. Keras can work with CPU and GPUs. Thank you for all the responses. You're able to understand. Akila ma'am, Pradeep sir, Professor Pradeep, and Bharanidharan sir. All right. So you're able to understand Keras is the front end and TensorFlow are the back end libraries. So between the layers, I told you, you keep that strong in your mind. Deep learning consists of deep neural networks. Okay. It goes between the inner layer and the outer layer. There will several middle layers available. So the backend that is working is the TensorFlow, and the front end that you're going to use a higher level API, that is Keras, which contains large number of deep learning models already available. You can use it. Okay, it runs on both CPU and GPU. It runs both on CPU and GPU. So today's session, we are going to see how are you going to import packages using NumPy, Pandas, and Keras and TensorFlow. I'm sorry, some of it is lost. Okay. pandas. We're going to use. Also making a note of it, we can make a note. TensorFlow. Okay. So I'm going to use this data set called for a diabetes data, PIMA. PIMA diabetes data set is the data set that I'm going to take, and using that I will be able to show you the demo. How are we going to develop a model? All right, how are we going to define the layers in which, and how are you going to compile it and fit it and evaluate it all right, so these are the four major packages that you're going to use: NumPy, Scientific Python, Pandas. Along with that, we use Matplotlib and Seaborn. You can make a note of it, Matplotlib and Seaborn too. So when you take deep learning process in deep learning application, what does a data scientist or analyst do? Step one, you need to understand whether the problem, and whether good deep learning is a good fit. That's the first thing. So for every application, some application machine learning algorithm itself gives a good solution. For some application, deep learning gives a data set and prepare them for analysis. Finding your data set is the most important thing. Either you develop a machine learning algorithm or deep learning algorithm. The reason behind the quality of the food that you eat, the taste of the food that you eat totally depends on the quality of the ingredients that you give. Yes or no? If you want to eat a really tasty food, it depends upon the quality of the ingredients that you add in the food. Yes or no? Yes. If you are going to give a good quality ingredients, then the food naturally turns to be tasty, and if it is cooked in a proper method and proper way. All right. If you are going to use ingredients of a lower quality, the taste also will be little lower. Do you agree with that? Yes, no? No, yes? Yes. Thank you, Nisha ma'am. So the same way here it works. When you take a data set, okay, I always encourage researchers to work with benchmark data set. All right, so choose the type of deep learning algorithms that you want to use, and then train your algorithm with large amount of labeled data sets and test the performance against unlabeled. Now by this time you will be understanding what is a labeled data and unlabeled data. So I told Keras can work with CPU and GPU, and then backend is TensorFlow, Athena, CNTKN, and now we are going to use TensorFlow, and the front end is Keras API. So this is the structure of it. Okay, so I'm going to use this data set called as PIMA diabetes data. Okay, so what are the columns? Number of times pregnant, okay, and plasma glucose tolerance, that they say it as glucose tolerance at GTT. How many of you have experienced it? I don't know, but you will be able to know about it. If you are pregnant, they take a glucose tolerance test. They give you a large number of a glass of glucose again and again, and they test whether you're going to have diabetes or not. The next column is diastolic blood pressure. The fourth one is tricep skin fold thickness. Then 2 hour serum insulin. BMI, the body mass index, weight by height. Okay, diabetes pedigree function, what is the age? And here the output, this is the label data. If it is 0, the person is not going to have a diabetes. If it is 1, the person is going to have a diabetes. So first you need to understand what are the columns available. 1, 2, 3, 4, 5, 6, 7, 8 columns are available, and 9 columns. So 9th is your target variable. It's your target variable. Okay, pregnant means number of times pregnant, the same thing only. So 1 means they have tested positive for diabetes, and 0 means they tested negative for diabetes. So this is how your deep learning model is going to work. I told it's a deep neural network, the input layer, the output layer, and the hidden layers. Okay, able to understand till now? Okay. Yes, no? Okay. So moving on to the demo session. Jesus. I've taken a very, 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 very simple model to make you understand how it works. Okay, how it works. Thank you, Professor Pradeep. Thank you, Professor Barney, sir. Okay, okay. First, I told you tensor is on the back end and keras is on the front end. So first, I'm using Colabs, Google Colabs. All right, and I'm using pip install keras and pip install TensorFlow. I'm installing two Python packages, the front end and the back end, the keras and TensorFlow. And you remember I told I'm importing pandas as PD. Okay, pandas is for Python for data analysis. All right, and NumPy is used for numerical Python. And I told we are going to develop a model using keras. So the keras has got a model. Inside the model, you have got layers. The model that I'm going to use for today's demo session is a sequential model. Remember, listen carefully. We are going to use a sequential model, and layer is dense. There are different models available. I'm choosing one such model, is sequential. There are different layers available. I'm choosing one such layer is dense. So now you are able to understand. So Keras has got a model. Inside the model, you've got different layers. So from the models, I'm importing only sequential. And so once I install it, so once I run this, already if it is installed, it takes, otherwise its requirements already been done. So I'm importing the necessary packages. Okay. Then what is the next step I'm going to do? I have my data set onto my Google Drive. So I'm mounting my Google Drive. Once it is mounted, I'm loading my data set. I told you, right? I'm using a diabetes data set. So I'm importing into this variable called dataset.headof. It has got 768 rows and 9 columns. Okay. And so here is it. All right. So this is the data set. So you how many times we don't want the name of the person or what it is, we want only the content. It is also taken from UCI machine learning repository, and this diabetics data set is also a benchmark data set. So number of times the pregnancy, what was the glucose level? You remember the glucose level I told? The glucose tolerance test. When for example, you can see the first and the second. See, when the glucose level is 85, you can see the person does not have diabetes. When the glucose level is 148, the person has got diabetes. Can you able to relate these columns to the target? 189, the person has got diabetes. 89, the person does not have a diabetes. Able to understand? Able to understand? So these are then the blood pressure. Okay. And what are the
Yes,
things
ma'am.
that, thank you, sir. What are the things that aids to it? The skin thickness, the insulin, okay, insulin level, how much it has been onto the blood, the BMI, you know, when they say when you're obese, and when we take, nowadays, if we take blood test, they're also saying, are you going to be a pre-diabetes? Also, they're able to find it out. All right, from a blood, the technology is growing every time. Before will be once they get diabetes only they can find. Recently, even you're going to become a pre-diabetic, which means you need to be careful on the usage of the sweetness that you use. Okay, the pedigree function, the age, and the outcome. But here, fortunately, we have all our data in its numeric, so there is no work on pre-processing to convert my numerical data into, sorry, categorical to numerical data. I'm not going to do that. And also, and so I have a data set dot is null of. I'm going to find dot is sum of is I'm going to have any missing values. See, there is no missing values. If I have missing values, I'll have number. So this is one such to find missing values. All right. And what is the type of this data set? Whenever you take a data from, see, I'm taking listen carefully. I'm taking a CSV file here, a comma separated file. Then I'm loading into pandas, import pandas as PD. It is converting into a data frame. It is I checked, there is no missing values. There is no categorical values. So these are the columns, data sets dot columns of, what are the columns available, and I'm going to group by outcome. So outcome, you remember what did I say? 0 means they don't have diabetes, 1 means they have got diabetics. So I'm giving group by outcome dot size of to find out. Is there any doubt? Somebody's mic is unmuted. Rashid sir.
No, ma'am.
Okay, thank you sir. So, okay, and I'm trying to understand about the data, and I'm grouping, and I'm planning to prepare a histogram, right? How the values, what are the values of the skin thicknesses, okay, the insulin, the BMI, all right, the pregnancy, the glucose, the blood pressure. Can I see there are some outliers here? Blood pressure cannot be 0, glucose cannot be 0. We need to work on with outliers. Okay, BMI cannot be 0. Okay. So these will be able to find out whether their outliers means, see, age of a person can be between, when I take age, I had one column as age. See, age, there is no outliers between 20 to 80. Age, in an age, if I'm going to have one value as 500, no, it is not possible, right? So those things, we need to curate it. You need to curate for outliers, the different algorithms and insulins, and these are, I'm just getting in one shot, and I'm finding, and this is, I told, this is about, I'm making a histogram using the pandas itself, all right. And here I'm importing a seaborn with the higher layer, SNS dot count of, SNS dot count plot of. So I'm finding with my outcome. So with this graph, what do you understand? Can one of you tell one of the inference? What do you understand from this? From this, what is the outcome? The person is going to have a disease or not. Okay. So 0 means, what does it say? One of you can say what is the inference that you. So in this data set, the people who have disease is less in comparison. Yes. Some of you are unmuted. Can you say, please? Yes. Is less. Okay. And also you can have heat maps. Can you see? You will be able to see the heat map that is generated. So this is low and this is high. Okay. I can also perform the correlations, and then I can send the correlation into the data heat map. Okay, default it takes the Pearson's correlation. Can you see? I'm performing a correlation of the datas between all the columns between pregnancy to outcome. The diagonal will be always 1, And can you see if the correlation is more, the color will be less. The correlation is less, the color will be dark. So when you see the target value with all the columns, leaving out outcomes, all of them have got a good level of correlation. If it is darker, then we leave those columns. They are where in your feature extraction takes place, wherein your feature extraction takes place. So heat map you can generate after computing your correlation. There are different correlations. The default is Pearson's correlation. There is also Kendall correlation and Spearman's correlation. So after this has been done, okay, then I'm going to split my data into features and target. So I'm going to drop my outcome. So X contains all the features and Y contains my target, and Y contains my target. Okay. So X contains the features and Y contains the target. So target means either it is zeros or ones alone will be there. When you see X, see here, X you can see other than the outcomes, you will have all the other things. Can you see pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, pedigree function, and the age. Okay. So now coming into models, do you remember we imported model sequential? Okay, I'm instantiating sequential model. So before I move on into it, I will show you what does the Keras provide. So Keras provides a complete framework for any type of neural networks. Okay, it's very innovative as well as very, very easy for you to learn. You using Keras, you can implement a simple neural network and also a complex neural network. Okay, so you can Keras API can be developed into three categories. One is the model. You remember we imported model sequential and we imported layer as dense. Do you remember it? Do you remember it? So here there are three things: the model, layer, and the core modules. In Keras, every artificial neural network is represented by Keras model. Okay, so every artificial ANN, the artificial neural network that is mimicking the human brain, is represented as a Keras model. It is composed of different layers. Okay, this model, you take an entire Keras model, it consists of different layers like an input layer, hidden layer, output layer, convolution layer, pooling layer, etc. Okay, I definitely you have an input, your output. The middle layers are called hidden layers, and you've got convolution layers and pooling layers. And every model and layers can access through Keras models for activation function, for loss function, for regularization functions. Okay, using this Keras modeling and Keras layering and Keras modules, any artificial any algorithm, CNN or recurrent CNN, okay, convolution neural network, RNN, okay, can be represented in a simple manner. So you should understand there is a model. Inside the model, there is different layers, and the layers also contains different modules. Okay, so when you see this picture, you'll be able to understand. This is a core modules. I told you, right, when you want to compile, you have an optimizer, laws and metrics, you have initializers, regularizers, and activators. The data set, these are core modules, callbacks and visualization. So we can use a sequential module or functional module. So for this example, I've taken sequential module. This module consists of different layers: core layer, convolution layer, pooling layer, locally connected layer, recurrent layer. So user modules. So you have a model. In the model, you've got different layers. Till that you can understand now. You remember you have a model that has got different layers, and you have a core modeling, and you have got a core modeling. So core modeling, core layers, convolution layers, pooling layers, and recurrent layers. These are the different layers in Keras. All right, wherein you will be able to develop your ANN. Okay, layers, these layers inside the model, you've got layers, right? These layers are the building block of your neural networks in Keras. So you have a model, inside the model you have got layers. These layers are the building block. So layers consist of tensor in and tensor out. You remember I told you TensorFlow is working at the back end. Keras is on to the front end. So it does a tensor in and tensor out computation functions and held in TensorFlow variables. Okay, TensorFlow variables, and it has got its own weighting. There are three models. Okay, three ways to create Keras models. The first model is what I've taken, that is sequential, very straight, single input, single output, and you have got inside that you have got different hidden layers. Different layers could be taken. Okay, and functional API is another next model where it is also easy to function. It is a full-featured API that supports arbitrary model architectures. For people, most places for industrial strength model, they go into functional API. If you are an expert in Keras modeling, The third model that you can use, model subclassing. Everything you would be implementing from scratch onto your own use. If you are doing a researcher, you can move on into model subclassing after you get versatile with your sequential model and your functional model. So the next step, once you develop a model, has got different layers, and then you need to go in for training and prediction. So training, evaluation, and prediction. So I told you, when you want to compile, there are three things you have to first you have to compile. In compilation, remember I told optimizer, loss function, and metric should be defined, and then the next step, you fit the model, and then you evaluate the model, then you predict the model. So these are the 4 steps available. First, you develop a model, define the layer. Once the layer is defined, then you compile it, then you fit it, evaluate it, and predict it. Okay. You remember the 8 steps we saw yesterday. So when you compile it, the most important arguments are loss function, optimizer, and metrics. Okay. Now coming into the demo session. See, I'm importing the Keras modeling, import sequential. Okay, I'm instantiating it. You remember I imported layers. So inside the model, you've got different layers. I'm using dense layer here, 12. How many layers? Then the input dimension, what are the activations, the ReLU or sigma, different methods are there. How do you activate the layers? You know, activation, regularization. So this is what it has been done. And once the model is defined, the layers are defined, I'm going for compilation. You remember I told compilation has 3 things: loss, optimizer, and metrics. Loss, optimizer, metrics. So what is the loss? I'm going to use binary cross entropy. Optimizer is Adam, and accuracy is metrics. I'm going to use this accuracy. So coming on to the presentation again here, there are different loss functions, but the loss function I've used here is a binary cross entropy. Optimizer is Adam optimizer. Okay, when you take Adam optimizer, it uses SGD, stochastic gradient descendant method, that is based on adaptive estimation of first order and second. So optimization here is using Adam. There are different optimizer available. And for this example, the loss I've used is the binary cross entropy. It computes a cross entropy between the true labels and predicted labels. Once I develop a model, true, I've got an answer. What is my deep learning model is going to give me predicted. So for binary classification, I use cross entropy loss, y true and y predict. Okay, I'm going to find the loss using the loss function I've defined is binary cross entropy, and the metrics is accuracy. Okay, 2 local variables. Okay, y predict and y true, and find how many, whatever is predicted is exactly that of the same, then I get 100%. After I do it, after I compile it, then I go in for fit and predict. So trains the model for fixed number of approaches. So what is the number of iterations that I'm going to do it on a data set for better accuracy? And on predict, I will be generating the output predictions for the input sample, because in my prediction model, I will not be giving my, what do I say? I will not be giving the labeled out. So now see, once I compile, develop the model, develop the layers, and then compile this using losses optimization metrics. And I'm fitting the model using 150 approaches, 150 iterations. For every iteration, you can see how the accuracy is keep on moving. Okay. And out of which it will take the best accuracy. Yeah, almost it's over. Yeah, 150 approaches have been done. Okay. And then once I fit my model, compile and fit, and then what is the next step? Remember, it's evaluating the accuracy. The most highest accuracy I've got it as 24 out of 24 approaches, where it is 77% I've got accuracy. You can see here, okay, 77 accuracy. And then what I'm doing, modeling, compiling, fitting, evaluating, and the next step is prediction. So I'm going to predict the predicted value. I'm going to compare it with I'm getting my predicted value from the modeling, whatever it has learned, the patterns of the data. Okay, once it has been done, and I've got my predictions here. Okay, I have my original results. I'm going to compare both. For comparing both only, I go in for my performance evaluation, the accuracy score. Can you see? I've got an accuracy score of 77%. Precision, recall, and F1 score. If I want to explain to that, it takes even more time. Okay, it takes even more time. So trains the model, and you generate your outputs for input samples. and performance I've done using accuracy and classification report. If you want to learn more about this technology on hands-on session, I'm giving hands-on session on my company. There are research scholars available with us. We train them and they develop on their own. And now for the students, we're providing winter internship. If any of you want to if you're new to it, I want to learn something about predictive analytics also, it is open for faculties and corporates also. 15 hours hands-on training as a college, as a group you can join. You'll be working with the exploratory data analysis, data visualization, curation, and predictive modeling. The uniqueness of my company is a Section 8 company. We have registered under Ministry of Corporate Affairs, Government of India. All right, and here you get a certificate. We are providing internship for both students and faculty. The reason behind, when you were a student, we didn't learn something that is new, that is used in today's technology. All right, but we need to upgrade ourselves. We have been using it, and most of them have joined also. Okay, so you'll be able to understand the difference between the deep learning and the machine learning model. We have seen how the deep learning, where are the applications could be done, what are the steps, and I showed you a demo of using with diabetes data center. Now I've shared a link with you. Quickly you can join through the link for a small quiz, and we'll see. You have, once you click the link, you have to give in your name. So let's see who's going to win. And okay, one of you have joined. What about others? So to recap, we started with deep learning and machine learning, the differences, recommendation system, how it works, how the AlphaGo works, how more accurate is deep learning in comparison with machine learning. The feature extraction and the classification goes hands on hand in deep learning, whereas in machine learning it was different. First you complete your feature extraction, then it is followed by the classification. All right, and then we have been seeing about the different applications, and then we moved on to the different steps of deep learning algorithms, and then how was the neural network, the Keras modeling, the Keras layering, the compiling, the fitting, the evaluating, the prediction, and your accuracies. So these are different steps. We have taken a very simple data set of diabetes data set. Only 3 of you have joined. Can we start with the quiz, or the others you're going to join? There are 40 people. Just click the link given on the chat. I'm again reposting it. Give your name and then join soon, please. Let's see. So many of you are here. So that this is the only confirmation that you're still connected. I have not started the quiz. Please come out. Be in the quiz itself. I wish many of you to join. Only from the talk, some simple 5 MCQ questions. Yeah, we got 4, 5. Out of 42, only 5 are here. What about others? Quickly join, please. Yeah, quick. Okay, I'm going to start. We don't have much time. I think I should complete by 3. It's exactly 3 now. All right. The first question. Yes, in which model does classification follows after feature extraction? Whether it is deep learning or machine learning or none of, only one of you have answered. Others answer fast. You have got 3, 2, 1. Yes. In which model classification follows after feature extraction? Only in machine learning. In deep learning, both goes hand on hand. So the correct answer is machine learning. Let's see who's the winner on the first round. Others also quickly join. The link is posted on the chat. Kalaivanan sir and Gomati ma'am are on the first place, and in which Kalaivanan sir is the fastest. Congratulations, sir. Okay, we move on to the next question, second question. Whether self-driving car is an example of deep learning model, yes, no, or maybe. You remember we saw on a picture of deep learning applications. The correct answer is yes. 7 of you have given the right answer. Well done. Let's see on the leaderboard who's on the top. Some of you have not given your names properly. That is what you are getting, Earthman and all. Yes, Bharani sir, you are the fastest, and Gomati ma'am is on the first place. On to the third place, it's Srinivasan sir. Okay. Dash supports simple neural network to very large complex neural network modeling. Which package? Whether it is Keras or TensorFlow. A simple neural networks to very large and complex neural network model. I told you the word, right? Simple to complex. Which Python library helps? The right answer is Keras. I'm so happy. Out of the 10, 7 of you have given the right answer. Moving on to the next question for the day. Let's see who's on the leaderboard. Yes, Gomati ma'am on the first place, Bharani sir on the second, Dr. Preeti on the third, and Maheshwari ma'am is the fastest. The fourth question for the day. Adam, I told about Adam, right? Whether it is an optimizer or loss function or matrix. Whether it is an optimizer or loss function or matrix. You remember? Ma'am, why do you ask questions? We are faculties, we are strong in asking questions. 7 of you, 8 of you have answered, and the time is up. Exactly right. I'm so happy most of you have listened to it. 6 of you given the right answer, and Adam is an example of an optimizer. Let's see who's on the leaderboard. Most of you are doing really great and well. Bharani sir on the first place, and he's the fastest. Gomati ma'am on the second, Lakshmi ma'am on the third. Let's move on to the final question, which is going to decide who's the winner for today. After the end, the winner can share their experience about today's session. All right. Metrics to compile. What are the metrics to compile Keras model? Sorry, it's not mode, it's model. Is it optimizer, loss, metrics, or all of the above? What are the things that we need to do compilation of Keras model? It's not mode, it's model. I'm sorry. There should be a yellow over there. Even people on YouTube, the link is given. You can join. All of the above, right? When you want a company, you need an optimizer to be instantiated with the loss function and the metrics. Here we go to find who's the winner for today. All of the above is the right answer. And the winner for today is Gomati ma'am. Congratulations, Gomati ma'am. Second is Bharani sir. And third is Hi. I don't know if you could tell your name. And most of you participated. Okay. Hope you enjoyed learning something about deep learning using Python. Okay. You can share your feedback about today's session. How was it? Did you enjoy? Did you learn something? Okay. And this is my contact details. Okay, if you want to learn on hands-on session, you can contact. And this entire thing, I think they are also streaming it on YouTube. I'm also streaming it onto the channel. I will share it with you. You can get it. Okay, if you like the session, you can like, comment, and subscribe to my channel. There are many things. Most of my event I posted because I've got more number of people subscribe to my channel, and they always wanted to listen if they are on college, and after some time also they listen to it. So I'm sharing my contact details onto the chat. Yes, Gomati ma'am, you can unmute and speak your experience. You are the winner for the day.
Good afternoon, ma'am. Thank you for the wonderful session. Previous session was also very helpful for us. I attended both of your sessions and enjoyed it. The way you take the session and keeping us more engaged is really a mind-blowing one, which we faculties should follow it. Thank you, ma'am. Thank you for the wonderful informations.
Thank you, Gomati ma'am, for the good feedback. Is that is always challenging, right? Whenever we take classes, whatever it is, making the people to interact. But a live session is different. So the physical session is different, but virtual sessions is more challenging. And any of you want any kind of research guidance, you could contact me. We have one-to-one sessions. We train and you develop on your own. You develop on your own because sometimes. Some of them they find difficulty in problem definition, developing, training, it's giving, but we don't develop and give, we train you and you'll be developing it. Okay. And any of your students are interested in internship, it's fully hands-on and it will be really useful for the students, and the students also can come for 3 or 4 months internship, both online or offline mode. And if your students are interested, you can mobilize about this event to your students, or from your college if you're going to send a set of students also, it'd be okay. So thank you so much for the opportunity given. Hope you enjoyed the session. Thank you all. God bless you. Over to Kalaiselvi ma'am. Thank you.
A very good afternoon, madam. First of all, this is Bharanidharan. A heartfelt thanks, Registrar and HOD, 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 and the faculty members and organizers for taking more pain to conduct this 5 days webinar, FDP. And we have learned a lot on privacy and on emerging trends and deep learning by Doreen madam. It's always inspired one. I used to take a lot of things from her usually. So my heartfelt thanks. During this pandemic time, we should not be idle always. So some more universities, Vels University is always standing first to provide this kind of webinars. So it will help us to shine in academics as well as in research to keep updated in the emerging technologies. So once again, my sincere thanks to all of the faculty members and to the Vale family. And also I wish you a happy Christmas, happy New Year, happy day to all. Thank you. Thank you.
A very good evening to one and all. Doreen, madam, thank you so much. all your sessions. I have heard many of your sessions. It will always be very lively. I used to take lots of inputs from how the way you deliver and talk. Thank you so much for your wonderful session, ma'am.
Welcome.
Okay. So I'm very pleased in thanking on behalf of Vistas. I thank our management. First of all, I thank our chairman, Dr. Aishri K. Ganesh, Vice Chancellor, Dr. Sriman Narayanan, Pro Chancellor Academics, Dr. Ati Ganesh, Vice President Academics Preeta Ganesh, Registrar Dr. Saravanan, Director School of Computing Sciences Dr. P. Mailvahanan, HODs of School of Computing Sciences and all faculty members of Computing Sciences. The first 5 days online FDP themed on the role of Industry 4.0 in research and higher education spread around 5 days. That is from 15th to 21st, 2021, was inaugurated by our Vice Chancellor, and the sessions were handled by resource persons, Dr. Ajanta and Dr. Hema ma'am on day 1. On day 2 by Dr. Rennie Robinson and Dr. Priyadarshini. Day 3 by Dr. Doreen ma'am and Dr. Asha ma'am. And day 4 by Dr. Jaya ma'am and Gomati ma'am. And the final concluded session was again by Doreen ma'am. Thank you so much, ma'am. I thank our HOD, Dr. S. Prasanna, all faculty members of computer applications, Dr. Sri Priya, Dr. Sumalata, Dr. Jayalakshmi, Dr. Prabhakaran, Dr. Kalaiselvi, Dr. Meenakshi, Dr. Nagasundaram, who were actively involved in organizing and moderating this online FDP program. And not the least, like I should convey a special thanks to Dr. K.Kalaiselvi for having coordinated this FDP from day 1 to day 5 and live streaming the session in YouTube. Hope this FDP was a great forum for knowledge sharing, highlighting the role of Industry 4.0 in research and education. Hope you all had a very good session. On behalf of organizing committee and audience, I thank each and everyone for having made this FDP a successful one. I wish you all a Merry Christmas and Happy New Year, and hope to meet you all again in our international conference scheduled in the month of March in the next year, in the year ahead, 2022. Thank you all. Have a nice day.
Welcome, ma'am. Wish you all a Merry Christmas and a blessed New Year.